All right, thanks everyone. I was asked to present today on some co-development of an ecosystem model that we've been doing at NOAA with the Lake Superior Technical Committee. So this is really part of a larger initiative in NOAA called the Changing Ecosystems and Fisheries Initiative, for which I am the Great Lakes lead. At the national level, this is a cross NOAA effort to safeguard marine and Great Lakes resources, coastal communities, and economies as our coastal ecosystems are changing. This is building on no investments in research modeling and decision making. So how can we take all of the tools that NOAA already has at its disposal, as well as develop new tools to really meet these evolving needs in ecosystem management? The aim here is to deliver reliable forecasts, risk assessments, ecosystem information, really whatever our managers need to be able to make decisions and adapt as these ecosystem dynamics are shifting over time. And as you can see at the map at right, there's a number of regions throughout the country with which we collaborate. There's an Arctic Alaska region, there's a joint East Coast region, joint West Coast, Pacific Islands, and then us here in the Great Lakes. Now, the thing is, at the broad NOAA national level, the Great Lakes is really different in terms of NOAA's involvement in fisheries research and management. We have a very different stance. And so our team was tasked with figuring out how we still pursue the goals of this larger national program, but make it fit for the Great Lakes. How can we use our role here to help all the folks in this room in the work that you do? And so we've kind of turned this into focusing on lake modeling and support for supporting collaboration for our partners throughout the region, where we really focus on three main buckets. Model development: where can we develop new tools, as is kind of one of NOAA's core skill sets, to help fill in gaps, generate new knowledge to inform fisheries research and management. Data sharing, whether it's those new tools we develop or existing models. How can we educate folks on the capacity that NOAA has, the information we have available, help them understand how that may fit into some of the work they're doing, and help folks to access those tools, which we know, we've heard over and over, can be opaque at sometimes. And then also research collaboration, where there's a kind of a matchup of capacity and skill sets. Where can we kind of jump in with folks and use the expertise throughout the region to kind of pursue projects fitting under this broader goal of developing that actionable information for ecosystem management. So one of the main thrusts of the national program is development of a new hydrodynamic model for each region of the country, with this figure showing the different model domains that are being developed right now. And we have this nice cute little box in here, but I'd like to point out that we have to fit 5 different lakes, which makes our job a bit harder. This is called the Modular Ocean Model version 6, or MOM6 for short. And it's a really nice modeling framework, and then it's directly plugged into global climate models, allowing us to take those global climate model projections and integrate them into our modeling framework for our region. So we want to use our Great Lakes MOM6 for developing new ecological models, describing fish habitats, providing, say, habitat information to GLaDOS users, those kinds of things. And really what we ultimately will do, though the model's still under development, is produce a number of different products, being multi-decadal hindcasts. So how can we give 3-dimensional representations of the lakes back in time to compare to all these biological time series we have to start to better understand these ecological environmental relationships? We'll also be producing projections and forecasts on multiple timescales, those being seasonal. So as we sit here in spring, maybe we could produce a forecast, say, what do we expect this summer to look like, right? We're coming out of a cold winter. NOAA forecast suggests an El Nino is coming. Maybe we could start to think about what our summer conditions might look like. Also interdecadal or interannual to decadal timescales, rather. So kind of that 1 to 10 year time horizon, thinking about the time horizon over which a lot of fisheries management decisions are made. And of course, those classical multi-decadal projections. What might the Great Lakes look like in 2050, 2060, etc. And so we have started work on our Lake Superior iteration of this MOM6 model, with some kind of plots here showing what our model outputs are starting to look like. We're able to generate currents. We're looking at modeling the temperature cycle throughout Lake Superior, and really tuning this model based on existing observational data from thermistor string moorings and things like that. I should also note that this hydrodynamic model has kind of a biogeochemical module plugin called Cobalt we're also starting development on. Eventually, once we have that, we'll be able to look at how nutrients cycle through our lakes, how mussels strip those nutrients, things like that, how it affects the lower trophic levels. So with this kind of new tool coming online, we want to really think about what that'll give us in terms of capacity for end-to-end ecosystem modeling. So this is where we're starting development of an Atlantis model for Lake Superior. So with this end-to-end ecosystem model, we can start to think about how these different environmental changes ripple throughout the food web. How do those complicated interactions among all these species play out at an ecosystem scale? And hopefully we can then use that information, do scenario testing to support fisheries research and management decision-making. For those unfamiliar, Atlantis is a three-dimensional ecosystem model that really integrates from water movement, nutrient cycling, temperature, right up through the food web, and you can even code in different fishing fleets and harvest scenarios and things like that. It has a number of different use cases. Again, really kind of the bread and butter here is a framework, a simulated environment to look at complicated ecological, environmental interaction. And of course, when you have that climate information, you can look at them in a hindcasted framework. What do we think happened in the past? Why do we think certain species increased or decreased, or project into the future? What do we think our ecosystem will look like going forward? You can do scenario testing, those what if questions. What if we get another Cisco boom? What if alewife take off in Lake Superior? What might that look like throughout the food web? And you can do qualitative decision support. There's a ton of parameters in here. Atlantis has a lot more fish population dynamics kind of capability than a lot of other ecosystem models, but it's still a giant, complicated system where you have errors propagating. So I don't want to say this is ever going to replace stock assessment or anything like that. That's not what it's meant for. Instead, this is a way to kind of game out those scenarios and assess kind of potential risks of different ecosystem trajectories based upon, different management decisions or things like that. And I also want to emphasize that we are approaching this in a co-development process with the Lake Superior Technical Committee, because thinking back to the goals of the Changing Ecosystems and Fisheries Initiative, right, it's to generate actionable information for management. We don't want this to be an academic exercise. We want to make sure that this is a modeling framework that is helping for Lake Superior. So the way we've approached this so far is constant communication with the Lake Superior Technical Committee, and we started this model from a past ecosystem model they helped to develop. There's a past EcoPath modeling framework for Lake Superior. We use that as our starting point. We then came to them and said, okay, based on this past model, what updates would you make? If we're starting a new model, what do you want to add? So one of those was walleye. We've already heard today that walleye is kind of a rising fishery in popularity. They're playing a more prominent role in the Western Arm, so we added walleye to the food web as kind of a new addition. For those who heard my talk yesterday, you'll be unsurprised to hear I made the executive decision to put pink salmon in there as well. So that kind of allowed us to start with this framework, and now we're kind of going back and forth with the technical committee to get their input and leads on where there may be data to help to parameterize this beast of a model. And we're using the technical committee meetings and email contact in between to kind of have that regular check-in and process and address hurdles, get their feedback on, uncertainties about particular ways for model setup. We're also starting to talk to them about what ecosystem scenarios they may want to test. This is, again, a hugely complicated model. You could tinker with specific nodes of it forever. So we hope to keep iterating and improving it over time, but at least in this initial setup, we want to understand what the priorities are so that kind of first generation of the model is at least well equipped to answer what are the high priority questions now. And so we're starting to chug along in this process. We've developed our model grid. This is what our horizontal grid looks like. Grid loosely defined, these polygons, based upon predefined, recently published ecoregions for Lake Superior that we further subdivided into nearshore and offshore zones based on the 100-meter isobath. This is also a three-dimensional model, so each of these polygons also has a number of vertical layers. So that hydrodynamics model underneath is tracking water movement, how temperatures change, how nutrients move throughout that three-dimensional space, and allows the ecosystem to react to that. We've defined our model groups now, and we've started to extract temperature and advection information from our prototype Lake Superior MOM6 model to start to drive this ecosystem. And so where we're at right now is really in calibration mode. There's a ton of information that goes into this. So as I mentioned, for our physics, we're using our prototype MOM6 model. For nutrients, we're getting data from GlenPO and CSMI cycle efforts. And then for the food web, as I said, we started with this past model. We're updating with new time series, for example, from Goldsworthy et al. Or similar recent papers of updated biomass estimates, and using some of the GLFC databases to look at stocking and fishing dynamics. So I wanted to deliberately try to leave some extra time for questions here and kind of pose some questions back to you all. What are the ecosystem scenarios of interest you think are high priorities for Lake Superior? Here are a few that we've already kind of received from the Lake Superior Technical Committee. So what if Dressenids expand a bit in Lake Superior? What could that look like? What if there's a population boom of non-natives? What if there's another spike of rough? What if alewives really take off? What if can we model what happened with this recent year class of Cisco we've been hearing about? What will happen if it happens again? But there's certainly a long list of things. We're really interested in continuing to gain input and expertise from folks throughout the region to help to craft this model. We also want to know if there are particular physical condition summaries, that could be extracted just from the hydrodynamics side that might be of interest to your work. Do you want to know what the surface warm layer looks like, what the stratification season looks like, some estimation of ice cover, things like that. We want to hear what folks can best use from these kinds of tools to inform your work. And then, or if you have input on what parts of the food web are changing rapidly, most uncertain, most variable, we'd be interested to hear that as well, or any other ideas. I really want to put this to you all, and I'll shift over to questions now. And we welcome your feedback as we try to, again, make this the most useful tool for everyone here.
Thanks, Joe.